In the last video, I mentioned that how data is stored is central to being able to use it. There are many solutions for data storage. One format is a database. A database is an organized collection of data, generally stored in tables and accessed electronically from a computer system. Companies typically use a database to keep track of their basic online transactions, provide information that will help the company run its business efficiently, or help managers and employees make better decisions. For example, a hotel booking site would use a database for their customer transactions. If a person books a room for a night, that data is captured in the database, and the room availability is updated in real time on all customer channels. Another example is online banking. When someone transfers money from one account to another using their mobile app, that figure is updated in the bank's database in real time, and the user is able to see the most up-to-date account balance. Data integrity and scale are two priorities for businesses that use databases. Data integrity, or transactional integrity, refers to the accuracy and consistency of data stored in a database. Data integrity is achieved by implementing a set of rules when a database is first designed, and through ongoing error checking and validation routines as data is collected. Databases, therefore, also allow businesses to roll back transactions to see data history. In our banking example, suppose the customer goes to an ATM to check their account balance. It's not the same as what's displayed on the mobile app. In this case, the bank needs the ability to roll back the transactions to identify the source of the problem. Perhaps the ATM is broken. Or perhaps the user didn't click the final transfer button on their app. This rollback integrity protects the bank from fraudulent claims and protects customers' money. Another priority when using databases is scalability. Going back to our example, suppose the ATM belongs to a global bank that has a large customer base and processes high volumes of transactions every day. They need a database that can scale to meet that demand. Or think about our hotel booking example. Websites that process global holiday bookings have millions of transactions happening every day that require transactional integrity at scale. Different cloud providers offer a range of database solutions. Let's look at a couple of the most common Google Cloud database services and their benefits. We'll start with Cloud SQL. Cloud SQL is a fully managed relational database management service, or RDBMS. It easily integrates with existing applications and Google Cloud services like Google Kubernetes Engine and BigQuery, and built on the performance innovation in Compute Engine. Cloud SQL is compatible with common database management systems and methodologies. It offers security, availability, and durability, and storage scales automatically when enabled. This makes it easy for organizations to set up, maintain, manage, and administer databases in the cloud. You might want to use Cloud SQL for databases that serve websites, for operational applications for e-commerce, and to feed into report and chart creation that informs business intelligence. Let's look at a specific customer example. Headquartered in Mumbai, India, Living Consumer Products runs two flagship products: a casual dating mobile app called iCrush iFlush, and a contextual digital platform, CDP, that provides digital marketing services to clients. By signing on to iCrush iFlush through Facebook, users provide details such as gender, location, and interest, as well as headshot images. iCrush iFlush stores this information in a database and displays it to other iCrush iFlush users through an algorithm depending on compatibility. Due to the large data volumes generated by iCrush iFlush and CDP, as well as the need to allocate scarce personnel and financial resources to business projects, Living Consumer Products decided to operate in the cloud from the beginning. However, testing and early experiences with public cloud services didn't meet the company's cost requirements. In addition, they felt that availability and scalability were non-negotiables, and they couldn't afford downtime that would drive users away. Living Consumer Products migrated iCrush, iFlush, and CDP to Google Cloud. Now they're running these services on Compute Engine to provide compute power, Cloud Storage to provide unified cloud storage, and Cloud SQL to run its relational database. This allows living consumer products to both store and retrieve large volumes of data, such as user images, in real time. We'll cover cloud storage in more detail in upcoming videos. By handing off to Google the time-consuming tasks required to set up and run a database, like applying patches and updates, managing backups, and configuring replications, you can save time and money and keep your focus on building great applications. Cloud Spanner is another fully managed database service, and it's designed for global scale. With Cloud Spanner, data is automatically and instantly copied across regions. This replication means that if one region goes offline, the organization's data can still be served from another region. It also means that queries always return consistent and ordered answers regardless of the region. For example, if someone in the London office updates information in the database, that update is immediately available for someone in the New York office. Consistency is critical to companies like Spotify. It provides users with music streaming services. If queries don't always reflect the latest change, this creates many challenges for the company. Spotify holds information about the objects it stores in the cloud. This is known as metadata. Migrating their metadata storage to Cloud Spanner gave them strong listing consistency, so they know their queries will always reflect the latest data situation. Cloud Spanner provides strong consistency and massive scalability, which means that for organizations, this is no longer a trade-off. Plus, it provides enterprise-grade security. This makes it ideal for organizations that want scalability for their databases, whether it's within a region or across the world. It's great for mission-critical online transaction processing. And because it's all managed, it dramatically reduces the operational overhead needed to keep the database online and serving traffic. Cloud SQL and Cloud Spanner are examples of databases that enable customers to manage high volumes of transactional data at speed and at scale. With Google Cloud Databases, businesses can build and deploy faster, deliver transformative applications, and maintain portability and control of their data. Databases are one of the two main types of data storage systems in the cloud. The second is data warehouses. Data warehouses allow businesses to unlock insights and take intelligent action. Watch the next video to learn more.